Hello everyone, this is Bharat Singla. I am a school student in grade 10th and a 5-star coder on CodeChef and expert on code forces. Today, let us discuss the problem maximum number of distinct elements from CodeChef's annual competition, that is the SnackDown and the qualifier round. The difficulty according to me is simple to easy, and like prerequisites are just programming fundamentals like arrays and modulo operator, its knowledge and all. And one thing I do want to bring into notice is that compared to its predecessor problems, the previous two, they were like the cakewalks of cakewalks. And this is simple to easy. So a huge difficulty drop, I would say, which is pretty indicative from its submission count as well. So as you can see, that 33,000 solves for the first one, then 29, like nice one, and then a massive drop to direct 9,000, which is almost a drop of 20,000 submissions. So that many people struggled, and this in a way means that this problem is not meant for division 3, right? But I'll still anyways explain it in very layman terms, very beginner friendly explanation. Fine. So now let us quickly just have a look at the problem. Right, so yeah, and remember I'll be explaining the solution this time in both C++ and Python. So stick around till the end. Language is not a barrier. So let's open the problem. So you are given an array B of length n. So what you are already given is B, an array. We want to find any such array A of length n again, where AI could be literally anything, and C is the array that is A modulo B. Now Ci is basically defined as AI modulo Bi for all I. We want to find such an array A such that this CIC array has the maximum number of distinct integers. And there could be many answers, just print any of them. So you have the number of test cases, then you have n and the array B is given. We want to output n integers the array A such that the array C that would be formed, that would be the modulos of corresponding AIB, like A0 modulo B0, A1 modulo B1, A2 modulo B2, like this the array that would be formed. We want that to have the maximum number of distinct elements. For that, print any such a. Great. So let's just have a look at one of the samples. So for 213, what we can do is we can print 312. So what happens is you take 3 modulo 2, right? This 3 modulo 2, then you have 1 modulo 1, right? The next you have 2 modulo 3. So this would be the corresponding array, right? 3 modulo 2 is 1, then 1 modulo 1 is 0, and 2 modulo 3 is 2. Now, as you can see, the maximum anyways we could have got was the whole array is unique, and yes, we could achieve 3 unique integers. Right, for the second array 1 1, it's obvious that any number modulo 1 would anyways be 0. Right, so no matter what you take, the array A, the resulting would always be 0 0, right? So the maximum number of unique elements you can get is 1, and 2, 3, or literally any array would fetch us an AC. So let's move on to the solution now. So maximum number of distinct elements. The first observation is that x modulo m always lies in the range from 0 to m minus 1. Nothing much to explain over here, like, like pretty basic to observe, right? Because for example, if I take 10 modulo 5, right? So this does not give you modulo, the remainder here is not 5. The remainder instead here is 0, right? So you can, to get a remainder 0, you can just take 5 modulo 5, right? To get remainder 1, you can take 5 plus 1, that is 6 modulo 5, right? This gives you 1. Then 7 modulo 5 would give you 2, right? 8 modulo 5 gives you 3, so on. Then you have 9 modulo 5, that would give you 4. But now, after 4, for 10 modulo 5, you will again get 0. So 0, 1, 2, 3, 4, that is basically like this is pretty self-explanatory. Basic property of modulo, well-known fact, that is anything modulo m would obviously lie in this range. Fine. So this was the basic observation. The first one that is important to solve this problem. Fine. So the next one is that since AI could be anything, right? We are completely liberal to take any AI because we saw that the constraint for AI is from 0 to 10 to power 9. It just means that just you can take anything, right? Any possible remainder can be achieved. So for example, with because let's say that we want to set AI to be something, right? the one that we are taking its remainder with is fixed. And what we want as remainder is, for example, 2. Right. So it's very easy, just set AI to be 2. Right. Just set AI to be 2 and you have 2 modulo 5 is equal to 2. To get a remainder 4, just set it to 4. Or you can set it to 5 plus 4, that is 9. So 9 modulo 5 would also give you 4. 4 modulo 5 would also give you 4. So for simplicity purpose, we can just take the remainder itself, right? And that would work fine. So this is like the basic few observations that are needed. And in fact, these are the only ones that are needed. So it's important to remember that anything modulo m will obviously lie in this range. And the next point is that if we know what we want as the remainder, right, then AI, since could be anything, as it could be anything, we can just, right, construct such an AI that gives you that remainder, right, which as we saw could be the remainder itself. Fine. So these are the basic observations that were needed. And now let us move on to the solution. So the next point we want to remember is that we want the maximum number of distinct elements, right? Maximize the number of distinct elements. What this means is that first we'll try to get the remainder 0, then we'll try to get the remainder 1, then we'll try to get the remainder 2. And remember, the problem literally boils down to what you want as the remainder, right? Because AI could be anything. When we are constructing the array, we can set the value to be anything. So any remainder is achievable. So the problem is basically to find such a way that we can maximize the number of distinct remainders. AI could be built, right? That's like something we can think about later. First, it's important to generalize an approach of what the pattern of the remainder should be. So we can go in a very, right, rudimentary pattern, that is just to take 0, so on. So to get remainder 0, right, we can set a number. To get remainder 1, we can set some number. To get remainder 2, we can set some number, and so on. And that literally is the solution. Now, one thing that is pivotal to the solution is that remember this fact, right? For any number m, its remainder range is nothing but m, the size of the remainders range, which means that taking some number modulo 10, right, the remainders have a choice from 0 to 9, whereas taking something modulo 100, right, or maybe 42, the choice, the possibilities of the remainder are obviously more. So the basically the space, the number of possible remainders achievable is directly proportional to m, which means that when we are trying to get the remainder 0, if in the array B we have 10, right, 10 gives us more possible options to get as the remainder as compared to 5 or 4 or a smaller number basically. So when we are trying to get a smaller remainder as the desired one, we must pair it with the smaller number in B. So for example, if the array B is equals 2, 1, 0, right, I'm just taking a random array B and I'm just showing on of what happens when you are taking the numbers in decreasing order. So we want to find any such array A such that on pairing up the remainders are that as distinct as possible. So first, to get the remainder 0 in our resulting array C, right, what we can do is just have 0 here, right? We have discussed that already, that whatever remainder we want, we can just take that in the array. So 0 modulo 2 will give us 0. Great. So we desire to get the remainder 0, we got it. Next comes the remainder 1. So as you can see, for this number, the only remainder that's possible is 0, right? But we wanted the remainder 1. So that is where we have to suffer. So here we have to just put anything here. Anyways, the remainder would be 0, right? So for that we can put literally anything, right? Any number. Then here, as you can see again, here it's 0. Now with 0, the range of remainders is like 0 only. You can just take these numbers to be 3, 2, 1 because remainder with 0 is not defined. But you get the idea, right? Basically, if you take the numbers in smaller order, then the possibilities of the remainder is decreasing the range, right? But the number that we desire as the remainder is increasing. That's the thought process we are following. We want to get the remainder 0, then 1, then 2. So to maximize this, the maximum times when what we desire gets fulfilled, it's better to take the numbers of B in increasing order as well. In algorithmic terms, I mean, yes, to sort the array. Because if, for example, I take this 210 array in increasing order, right? So if I take it as 1, 2, 3, right? Like for example, this is if this is 3, 2, 1. So if I'm taking 1, 2, 3, so now what happens is that our desired array of remainders is 0, 1, 2. So yes, for 1, it is possible to get the remainder 0, right? For 2, it is possible to get the remainder 1. For 3, it is possible to get the remainder 2. Accordingly, we can build the array A as well. Like here we can put 0, 1, 2. Fine. So because our the basic thought process, just to summarize, right? I want it to be as elaborate as possible, the explanation. So what we can do is just to quickly summarize the explanation. We want, like, remember these two facts first. Any number modulo m will lie in this range, which also means that a greater space for more number of possible remainders. Observation 2 is that if we just have a thought process, a fixed approach on what the remainder should be, if we fix that, because AI could be anything, there's no constraint given in the input, we can just use that same remainder or whatever it is, any possible remainder is achievable, and we could set AI accordingly. Fine. So these were the main two observations. After that, we saw that one approach that does work is to first try to get remainder 0, then 1, then 2, then 3, so on. And because again, from the first observation, we know that with the increase in number, we have more possibilities for the remainders, and because our what the number we want as the remainder is increasing, it's better to take the array in increasing order as well, right? Like for this example we saw here is that if I take the array B to be equal to 3, 2, 1, right? Then to get my array C, to get the remainder 0, I can get it. To get my remainder 1, I can get it. But here to get my remainder 2, right, it is not possible because 1, the range of remainders of 1 is only 0. But we want 2 here. So that was a shortcoming. We had to, trade it off here. But if I take B, now I sort the array B. That is, I take 1, 2, 3. So as you can see, I can get the array 0, 1, 2 because one's range of remainders is 0, two's range of remainders goes up till 1, so that is also achievable, and three's range of remainders goes up till 2, so that is also achievable. One shortcoming of this approach though is that we have to print the array so that it corresponds with B, but after sorting we lose the reference or the linkage to its indices, right? So now this is like a hack, a workaround, that instead of storing the array B, we can store it as a pair of the number as well as its index. So even after sorting, because we are storing it as a pair, so if for example the input array was this, so we store it as 3 comma 0, then I have 2 comma 1, and then I have 1 comma 2, right? So these were the numbers of the array, right? And these were the indices. So now what happens is that even after I sort it, right, the sorting will be by default in C++ or in any language happens in lexicographic ordering. That is, it will basically be sorted based on these numbers only, right? And but what will happen is that, okay, so first this would come because 1 is the smallest value. Then the next pair would be 2 comma 1. The next pair would be 3 comma 0. So now what happens is we do not lose the reference to the indices. So we know that 1 was at index 2, right? This index 2 was at index 1, right? And 3 was at index 0. Fine. So this is a general trick whenever you want to sort an array and don't want to lose the reference to its indices. Just instead of storing it as a normal array, store it as the array where each element is a pair of the element as well as its index. So now let us move on to the code through which you'll understand the approach better. And I'll be showing the code in both C++ and Python. Okay, so I have the sample input here, right? So I take the input for the test cases, right? I input that and then I run a loop that many times. So what do we have inside the loop? Well, we have an integer n, right? Then as I told you in the explanation, we are not going to simply store the numbers in the array B. We'll instead, for each number, I just take in the input for bi, and in B I push the pair of bi as well as I. right? So that's the same I drew in the explanation. Now what happens is when I sort this array, right, it automatically gets sorted based on the first element, right? But we do not lose the reference to the index. Fine, so we have sorted it. Now we want to build the array A, and what we want as the remainder is currently 0. So now I use object destructuring. Now you can look this up on the internet. This is a way to directly destructure, decompose the pair into the element as well as its index. You can write it in such a way. So I don't have to write pair dot first, pair dot second and all for readability basically. So I check that if want is less than equals bi minus 1. So what we want as the remainder, if that is possible to be achieved. Remember for bi, the range of its remainders is from 0 till bi minus 1. So if this remainder is possible for bi, I just set ai to that because want modulo bi, right, would give us want only because again want is less than equals this number. So a smaller number modulo a greater number is obviously that smaller number only. And then I can just increment my want. So in the next iteration, I want 1 as my remainder. Otherwise, otherwise what happens is you can just write ai equals 0. It could literally be anything because this does not basically lie in the range of its possible remainders. We already have gotten them. We want the want as the remainder, but that is unfortunately not possible. So this is the place basically where we are not going to get another distinct element. So then I just output the array A. So remember what happens is that now because we had a pair of the element and its index, when we are iterating on the sorted array B, but when we are assigning values to the array A, we are doing it based on what the index of that element was. So we are not setting A0, then A1, then A2. Instead, for example, for this array, the smallest element, or let's just take up this array, or the smallest element is 1, right? So this, the array here would be 2, 0, right? 2, 0. The next pair would be 1, 1, and the next pair would be 3, 2, right? So that's what the array was initially, B was initially. Then once we sort it, right, what happens is that it's basically because bi is the first element of the pair, right? That would be the array would be the sorted in the normal sorting manner only. So it would become 1 and 1, right? Then it would be 2 and 0. Then it would be 3 and 2, right? Simple sorting of the array. But now what happens is now when we are iterating here, right, we go on 1 and 1, then we go on 2 and 0, then we go on 3 and 2. So what happens is that in the array A, right, what happens is that on the on the first place instead, not on the 0th place. Remember, because 1 we want to match whatever we are putting here, right, that we are matching it with 1. So that has to be placed on the place where 1 was in the array B. So if these were the three spaces in the array A, at the first position, at the first index, right, because 1 was at the first index. So here in the first index, I place what I want as the remainder, that is 0 initially. And now since that was possible, I increment 0 to be 1. So in the next iteration, I want 1 as the remainder. So it's the next number, 2 is the next smallest number. So yes, the range of remainders of 2 is from 0 to 1, and yes, I want the remainder 1, I can get it. So where was 2 initially? 2 was here. So I set a of I, right, and here I set what I wanted as the remainder, that was 1. Then I come to the next smallest number, that was 3, which was also at the second index. So at the second index I set 2 now, right? We incremented what we wanted 2 now, and again 2 does follow in the range of remainders of 3. 2 is achievable if we are taking something modulo 3, and 2 modulo 3 itself is enough, right? So we get 102. So what was the array B? It was 213, and now what happens is that 1 modulo 2 is 1, 0 modulo 1 is 0, and 2 modulo 3 is 2. So all the three numbers are distinct. Right. The basic aim basically here was to somehow keep track of the indices, because in the end A and B will be taken correspondingly. Right. So that was the tricky part here. This is like again a well-known trick on when you want to sort the array but don't want to lose the reference or the linkage to its indices, store a pair of the number and its index instead of just the number. So that's basically the approach. Let's quickly run it. So we get this output, right? That was exactly what we saw. for others also we get this output. That seems correct. Now let's come on to Python code. Although I have explained the core logic in the C++ itself, just hovering over this one. Input for test cases. Python code is such short. Then I have the input for n. Then I have the input array. Right. So I set b equals again input of I as well as I. And yeah, if you have skipped over the C++ part, please go back. I'm just touching upon uh, the implementation in Python. I have explained the core logic and the nitty-gritties in C++ part. So even if you do not understand that, at least understand the logic and come here. Right. I'm not explaining everything again here. Just showing you the Python code. So if you're a Python user, you can refer to this. So I just store again the pair of number and its index in the array B. I sort it. Then I have an array of size n. If I initially set the desired remainder as 0, I go on all the numbers and its index. If want is in its range, right? So want is, what we want as the remainder, that is achievable because it lies, right, with anything modulo bi would lie in the range from 0 to bi minus 1. So if that is in that range, right, good enough, just set ai to that, or you can also set it to bi plus want, because that would also give us the remainder want, or bi plus 2 times want, or whatever, right? We just want that ai modulo bi would give us want. So the simplest is to just set it to want, and you can increment want for the next iteration. We already have got the remainder 0. To get distinct elements, obviously the next time we'll want 1 as the remainder. Otherwise it does not fit in the range, you can put anything here. Fine. So yep, in the end just finally print the array. So that is the code in both the languages. Let's quickly submit it. So I've already pasted the code here. Let's hit the submit button and get it evaluated by the online judge. And yeah, you can always ask me your doubts in the comment section. I'll be keen to reply to them. And hit a like button if you understood the explanation. Share it with all your friends who gave the contest and maybe struggled with the problem. It would really help them out. And yeah, this just wraps up the video. Let's hope for an AC. Okay. So great. It does get accepted.